Have you ever wondered what the physics of golf are? Have you ever wondered why Tiger Woods and other golf pros are so good at what they do? In this video, we will talk about some of the principles of golf and utilize Servite's own Brian Franke to demonstrate them.
When examining the physics of golf, we'll be using the data we have acquired from the monitoring system at Roger Dunn Golf Shop, as well as information from online resources.
The topics that we will be covering in this video are kinetic energy,
Potential energy,
ball launch velocity,
and the momentum of the club head.
After examining Brian's last swing, we decided to find the kinetic energy of the golf ball at its impact. The equation for kinetic energy is kinetic energy equals 1/2 mass times velocity squared, where m equals the mass of the golf ball in kilograms, and v equals the velocity of the golf ball at impact measured in meters per second. We used information for mass from the Titleist Golf Ball website and velocity from the launch monitor at Roger Dunn Golf Shop that examined Brian's swing. We used the equation to find that the kinetic energy of the golf ball is equal to 1/2 0.0459 times 59.0093 squared. The kinetic energy then equals to 79.914 joules.
After examining this ball flight on the launch monitor, we will now look at the potential energy of the golf ball at its peak. The equation for potential energy is potential energy equals mass times gravity times height, where m equals the mass of the golf ball in kilograms, g equals gravity, and h equals the height of the golf ball at its peak. We then used our data to find that potential energy equals 0.0459 times 10 times 29.67. Potential energy then equals 13.619 joules at the golf ball's peak.
For this last swing that Brian took, we will now look at ball launch velocity. The equation for ball launch velocity is VB equals quantity of S times 1.67 divided by the quantity of 1 plus B divided by H, where VB equals the ball launch velocity, S equals club head speed, B equals mass of golf ball, and H equals the mass of the club head. With our data, we plugged in the equation to be that VB equals 40.68 times 1.67 divided by 1 plus the quantity of 0.459 divided by 0.254. The result of this is that the ball launch velocity equals 57.538 meters per second.
After examining Brian's last swing, we'll now look at the momentum of the club head during the swing. The equation for momentum is P equals mv, where P is the momentum, m is the mass of the club head measured in kilograms, and v is the velocity of the swing, also known as the swing speed, which is measured in meters per second. Using our data, we use the equation P equals 0.254 times 40.6806, which equals 10.333. The momentum of the club head during the swing is 10.333 kilogram meters per second, or Newton seconds. In conclusion, we have learned that there are many physics concepts in the game of golf. PGA professionals have perfected these physics concepts in their game and use them to their advantage. For example, PGA players are able to generate a large amount of momentum in their swing, which increases the distance they are able to hit the ball.
Also, heavier clubs generate more momentum. This is why clubs with more loft are heavier, for these clubs generate a higher ball flight and a greater amount of potential energy.